Hi, in this video, we are going to do a slightly advanced problem on circles. So it involves multiple circles and let's get into it. It will cover a lot of your theory for circles and you will learn quite a lot from this problem. So let's see this question. Let S1 be a circle passing through 2, 0 and 0, 2 and having the smallest possible area. Okay. S2 is a circle touching S1 externally and passing through the origin. Passing through the origin. S3 is a circle that touches both S1 and S2 externally. Now, the question says if the area of S1, S2, and S3, area of S1, S2, and S3 is the same, we have to find several things. Equation of S2, equation center of S3, equation of smallest circle, equation of smallest circle containing S1 and S2, containing S1 and S2. That is the third thing you have to find. And the fourth thing that we have to find is circle, the radius of the circle, radius of the circle that intersects S1, S2, S3 orthogonally. Radius of the circle that intersects S1, S2, S3 orthogonally. So there are multiple things to find out in this problem. And the only way to approach this is to start from the beginning and slowly figure out each circle equation. So let's start by trying to figure out S1, S2, and then S3 equations. Once we have that, we'll be able to answer many of these questions, right? So our attention should be on this part right now. S1 is a circle that passes through 2, 0 and 0, 2, and it has the smallest possible area, right? So think about it. The circle, 2 points on the circle are given, 2, 0 and 0, 2. If you have a situation like this where these are random points on the circle and the line joining 2, 0 and 0, 2 is any random chord, then the area of the circle will be quite big. However, the minimum possible area will come when 2, 0 and 0, 2 becomes the diameter, right? 2, 0 and 0, 2 should be the diameter of a circle, and that will be the smallest possible circle, right? If, think about it, if 2, 0 and 0, 2 was not the diameter, then that circle will definitely be larger, right? So because they have said that it has to be the smallest possible area, S1 is a circle where the endpoints of the diameter are 2, 0 and 0, 2. Therefore, we know the length of the diameter. We know the diameter will be having a length of 2 root 2, and therefore the radius of the circle will be root 2. And that is the radius of S1, and also the center of S1 will be the midpoint of these two. So that will be 1, comma 1 is the center. So let's do it on the next screen. S1 equation becomes simple. X minus 1 whole square plus y minus 1 whole square is equal to root 2 square. And how did I figure it out? Because it has to have the smallest possible area, and it also has to pass through 2 comma 0 and 0 comma 2, which means that those 2 points must be the endpoints of a diameter, right? So the S1 equation, after simplifying this equation, you will get x square plus y square minus 2x minus 2y is equal to 0. That is my S1. Now let's think of S2. And first of all, notice that S2 touches S1 externally, and S1, S2, S3 have the same area. So the radius of S2 is also root 2, because radius of S1 we have found is root 2, right? And if it touches externally, the center of S2, C1, C2 should be equal to R1 plus R2. This is the condition for externally touching circles, right? We already know the center of S1, that is 1, comma 1. And now the center of S2 will be such that this will be true. Also, the radius of S2 is root 2. So if they have also given in the problem, S2 passes through the origin. S2 passes through the origin. So this is all the information that we know about the circle. This is enough to find the circle. Any circle that passes through the origin will have the equation like this. The C term becomes 0 since it passes through the origin. So the center of the circle is minus g minus f. And the radius of the circle would be root over g square plus f square. And that is supposed to be root 2, right? Because we know this. We get g square plus f square is equal to 2. That is one condition. And this condition is C1, C2 is R1 plus R2. R1 and R2 are both equal to root 2. So the right hand side here is 2 root 2. And C1, C2 will be g minus 1 whole square. Actually, it will be minus g is the center. So it will be minus g minus 1 whole square plus minus f minus 1 whole square is equal to 2 root 2. And this is under square root. So we get minus signs will go away, and it will be g plus 1 whole square plus f plus 1 whole square is going to be 8. And this becomes g square plus f square plus 2g plus 2f plus 2 is equal to 8. We already know g square plus f square is 2. This is 2. So we are getting 2 and 2 get cancelled and becomes 4. And we get g plus f is equal to 2, right? So g plus f is coming out to be 2, and g square plus f square is coming out to be 2, right? The only solution for these two is g is equal to f is equal to 1, right? So you can solve the quadratic. You can put f is equal to 2 minus g into this and check it. You will get only g is equal to f is equal to 1 fits. So therefore the center of this circle is minus 1 comma minus 1. And the equation of the circle S2 becomes x square plus y square plus 2x plus 2y equals 0. So that becomes your S2 equation. So we have found two of the circles, and both the circles pass through the origin, and actually they will be tangent to the origin, tangent to each other at the origin. One circle has center at 1 comma 1, and one circle has center at minus 1 comma 1, minus 1. So basically the centers lie on the line y is equal to x, and it's almost like the S1 and S2 are reflections of each other about the origin. This is one circle and this is another circle. They touch each other at the origin, right? This center is minus 1, minus 1. This center is 1, 1. Radius is root 2 and radius is root 2, right? Now we need to find a third circle. The third circle, S3. S3 touches both S1 and S2 externally. S1 and S2 externally. And radius of S3 is supposed to also be root 2, which is equal to radius of S1 and radius of S2, right? So we now need to find a third circle which is equal in size to these two circles, and is going to be touching both these circles. So it is obvious that the third circle should touch it like this. Somewhere here you can make the third circle, and you should realize that the center of the third circle, it could be here or it could be here, right? Touching both of them. So you have a system of three circles which form the vertices of an equilateral triangle because the radius of this is same as this, right? So the center of this circle could lie anywhere on the line perpendicular to y is equal to x. The center of the third circle will lie on the perpendicular bisector because these triangles are equilateral, right? So we can say that the line perpendicular is y is equal to minus x. So the center of this third circle could be h comma minus h, right? And the radius of the third circle is root 2. So using the condition again, C1, C2 is equal to R1 plus R2. And let's take C1 as 1 comma 1. And we'll do h minus 1 whole square plus minus h minus 1 whole square root over is equal to 2 root 2, right? And from here, you can solve this and you'll get h minus 1 whole square plus h plus 1 whole square is equal to 8. And this becomes 2h square minus 2h and plus 2h gets cancelled. Plus 2 is equal to 8. You get h square is equal to 3. H is equal to plus minus root 3. So if h is equal to plus minus root 3, the center could be root 3 comma minus root 3 or minus root 3 comma root 3. And that's why you have two possibilities for S3. Either S3 is here or S3 is here. Either in the second quadrant or in the fourth quadrant. And the equation of S3 can also be obtained easily now because we know the center and the radius. The equation will be something like this: x square plus y square minus 2 root 3x plus 2 root 3y plus 4 equals 0 after simplifying. This could obviously come with a negative sign or a positive sign. It could be minus plus and plus minus here because you have two possibilities for S3. So knowing these three things, we can already find out option A. We have found the equation of S2, the smallest circle containing S1 and S2. The smallest circle containing S1 and S2 would be a circle like this, centered at the origin. You should imagine a circle containing S1 and S2. It would be a circle like this, centered at the origin, and origin is 0, 0, and the radius of that circle would be simply 2 root 2. You can imagine this radius will be the radius of that circle that contains both S1 and S2. So radius will be 2 root 2. So option B was saying smallest circle containing S1 and S2 would be x square plus y square is equal to 2 root 2 whole square, which is 8. So option B is correct. Option A is equation of S2 that we have already found. Center of S3 we have already found. It is minus root 3 comma root 3 or root 3 comma minus root 3. The only part that is left is we have to find the radius of the circle which cuts S1, S2, S3 orthogonally. So let's first write the equations. The equations are like this. S1 is this. S2 is this. X square plus y square plus 2x plus 2y equals 0. And S3, for now we can take it to be in the second quadrant or in the fourth quadrant. So let's take it to be in the fourth quadrant. So you'll get x square plus y square minus 2 root 3x plus 2 root 3y plus 4 is equal to 0. This is the fourth quadrant version of S3. Obviously, there is another version of S3, which is the second quadrant version, but it is just going to be plus here and minus here, right? So these are my three equations. We need a fourth circle S4 that cuts S1, S2, and S3 orthogonally. Now there are multiple ways to do this problem. One way to do it is to assume x square plus y square plus 2gx plus 2fy plus c equal to 0 is the equation of S4. and use the condition of orthogonal intersection. S4 intersects S1 orthogonally. So what is the condition for orthogonal intersection? You should know that it is 2G1 G2 plus 2F1 F2 is equal to C1 plus C2, right? So you'll get one equation from here. What is the equation that comes? You'll get 2G and G2 will be from S1, and that you can see here is 2G, here is minus 2, so G is minus 1. So 2G into minus 1 plus 2F into F2 from here is again minus 1 is equal to C1 plus C2. So it is equal to C plus 0, right? So C here is C and 0 is the 0 here, right? So you are getting one equation, minus 2G minus 2F is equal to C. That is equation 1. Similarly, S4 intersects S2 orthogonally, right? So again, using the same thing, but with this equation, we will get 2G and G there is 1. So 2G plus 2F is equal to C, right? This time you get C1 plus C2 is C plus 0, right? Okay, so 2G plus 2F equal to C. This is the second equation. And S4 intersects S3 also orthogonally. So from here we get 2G, S3 is G. So here 2G is minus 2 root 3, so G is minus root 3. So 2G into minus root 3 plus 2F into root 3 is equal to C1 plus C2. So C plus 4, right? So we have basically another equation, 2 root 3F minus 2 root 3G is equal to C plus 4. So this is the third equation. And from these three equations, I should be able to find G, F, and C, right? So if you add the two equations, 1 and 2, you can easily see that C is equal to 0, right? So if C is equal to 0, now we are ending up with this equation and this equation. You have G plus F is 0 and you have 2 root 3 G F minus G is equal to 4. So from here you get 2 by root 3 is F minus G. If you add the 2, you get 2F is equal to 2 by root 3. F is equal to 1 by root 3. And therefore G is equal to minus 1 by root 3. So now we know everything about our fourth circle, F, G, and C, right? So the fourth circle equation is becoming, I will just write it here, F, G, and C are known. So the equation of the fourth circle becomes x square plus y square minus plus 2gx, so minus 2x by root 3 plus 2fy, so 2y by root 3 is equal to 0. And what is the radius of this circle? Radius of this circle becomes root over f square plus g square, so 1 by 3 plus 1 by 3 minus 0. So radius of this circle is root 2 by 3, and that is the correct answer. So here, when we got the question and we were told that S1 and S2 and S3 are being cut orthogonally, we are using the condition that an unknown circle cuts three given circles orthogonally, right? And that way we have found the problem. However, there is an alternative approach. You should know that when a circle S cuts three given circles orthogonally, and these three given circles are S1, S2, and S3, then the circle S basically is called the radical center of the three circles. What is the radical center? You can understand it in this way, that radical center is the center of a circle. I should not say center, I should say radical circle. Circle S is the radical circle of the three given circles. What is the meaning? It is basically the circle which cuts three given circles orthogonally. Let's say these are my three given circles, S3, S1, S2. This circle is the circle S, which cuts orthogonally all these three circles. An orthogonal intersection means the angle between the tangents is 90 degree at the point of intersection. Such a circle is called the radical circle. And how do you find the radical circle? So the radical circle can be obtained by first finding the center. What is the center? Center is known as radical center. How do you find radical center? Solve any two of the radical axis. Two of the radical axis of pairs of circles. So what do I mean by that? So radical axis is the locus of points from where equal tangents can be drawn to two given circles. And the equation of radical axis for any two circles will be the equation S1 minus S2. This equation is the radical axis of S1 and S2 circle. Similarly, equation of radical axis of S1 and S3 would be S1 minus S3 is 0. And these radical axes are straight lines. Similarly, the third radical axis would be S2 minus S3 is equal to 0. These straight lines will intersect at some point. That point becomes the radical center. This is radical axis 1, this is radical axis 2, this is radical axis 3. That point is the radical center, and that is the center of the circle S. So in this problem, since we know the three equations, I can easily find radical axis of S1 and S2 will be subtracting the equations S1 minus S2 is equal to 0. You will realize that S1, if you remember, was x square plus y square minus 2x minus 2y, and S2 was x square plus y square plus 2x minus plus 2y. So this will become minus 4x minus 4y equals 0, or x plus y equals 0. So that is the radical axis of S1 and S2. The radical axis of S3 and S1 becomes S1, S3 minus S1 equal to 0, and it will start looking like this: root 3 minus 1x minus root 3 plus 1y minus 2 equal to 0. You should subtract the two equations and check. This is my two radical axis. All the three radical axes will be collinear or concurrent. And since they are concurrent, we can solve any two of them to find the intersection point. So if you solve those two, you will get intersection point here would be radical center. And that comes out to be, again, the same thing that we got in the earlier approach. That came out to be this, right? This was the same thing that we got when we used direct orthogonal condition. So this becomes a radical center, and now all we have to find is to find the radius of this circle. So let's draw the figure to understand what is going on here. So let's say this is my circle, and this is my radical circle, and it cuts orthogonally S3. Let's say this is my S3 circle. This is my S circle. And this is my radical center. And this we have found out to be 1 by root 3 comma minus 1 by root 3, right? Now, what is the meaning of orthogonal intersection? Means at the point of intersection, the tangent to S circle is perpendicular to the tangent to S3 circle. At point P, this is tangent to the third circle. This is tangent to the first to S, right? And these two angle between the tangent is 90 degree. Therefore, we can say that this tangent must pass through the center of S3, C3, right? So this tangent must pass through the center of C3. So now we can join, and this tangent must pass through the center of the radical circle, right? So basically we have drawn two tangents, and since the tangents are perpendicular to each other, they will pass through their respective centers, right? Great. So now if the radius of this circle is r, the radical circle radius, we already know this radius is root 2, and we already know this much because we know this distance, because we know the location of this center. The location of this center, center 3, was actually minus plus root 3 comma minus root 3. root 3 comma minus root 3, right? Because we had taken the circle to be in the fourth quadrant, right? So we know the distance formula from here. So let's do that. So that will be root 3 minus 1 by root 3 whole square plus minus root 3 minus minus. So again, same thing. Root 3 plus 1 by, it will be minus root 3 minus minus, so plus 1 by root 3 whole square. So basically twice of this term. So it becomes root 2 times root 3 minus 1 by root 3. That is this distance, right? So now by Pythagoras theorem, we can find out actually the r, right? We can say r squared plus 2 is equal to the square of this. So that is 2 times root 3 minus 1 by root 3 whole square. So that becomes 2 times 3 plus 1 by 3 minus 2. So this is becoming 10 by 3 minus 2. So 10 by 3 minus 2 is actually 4 by 3. So 2 into 4 by 3, r square plus 2. And you're getting r square is equal to 8 by 3 minus 6 by 3. Notice r square is coming out to be 2 by 3 and radius is coming out to be root 2 by 3. So by simple geometry and understanding the meaning of radical center and radical axis, we are able to find the radius of the radical circle. So understand this idea that if a circle cuts another three given circles orthogonally, then that circle is the radical circle of the three circles. How do you find that radical circle? You can do it by taking the radical axis of any two pairs of circles, solving them to find the center, radical center, and then drawing this figure to realize that since it is orthogonal intersection, we can use Pythagoras theorem to find the radius of the radical circle, right? Another way to do the same thing would be to assume the radical circle to be unknown, and we need to find three constants g, f, and c. And since the radical circle cuts all the three circles orthogonally, we can use the 2g1 g2 plus 2f1 f2 is equal to c1 plus c2 condition three times to get three equations and then solve them to find g, f, and c. So that is the easier first approach. The second approach using radical axis and all is slightly trickier. You need to know that theory first. So that's it for this problem. I hope you have learned all that we needed to understand in this problem. It covers several concepts. The first few parts of the problem were simply finding the three circles. And last part was understanding radical axis and radical centers. So that's it for this video. I'll see you next time.